Welcome back. We are continuing our discussion of this example from chapter 24. We performed the hypothesis test last time and we determined that there was a significant difference after these men had used this exercise device 3 times a week for 20 minutes after 6 weeks, that their resting pulse rates on average decreased by a significant amount during that 6-week period. So since we know that there is a difference, the question now is, how big of a difference was there? To answer that, let's calculate a 95% confidence interval for the mean difference for the entire population of men who might use this device. Okay. So, we've got our basic confidence interval formula here. The center of the interval, where we're going to be adding or subtracting something from, is going to be the sample mean of our differences, x bar d. We're going to add or subtract the margin of error, which is going to be our critical value. And since we're dealing with just this data set right here, finding our t star, remember our degrees of freedom is just n minus 1 again. So finding that t star should be a little easier than it was with 2 independent samples in the last chapter. And then we've got our standard error of the sample mean here, which is going to be what was in the denominator for our t-score formula. That's going to be the standard error of the differences over the square root of n. Okay, that's our standard error. This is our margin of error. So it's going to be our sample mean plus or minus that product. So we know what most of these things are already. From our last example, our sample mean was, let me just pull it out here, negative 2.8 plus or minus. We'll leave the critical value here blank for just a second. Go ahead and fill in what we know here. The standard deviation of this data set from one of our stats was 2.53, and our sample size is 10. So, as it usually is with calculating these confidence intervals, the critical value is the only one that you probably won't have in front of you already. It's important to know how many degrees of freedom you have. So in this case, that number is 9. So, this is where, if you've got inverse t, this is where you'll use it. We want a 95% confidence interval. So we'll just sneak this in here. You can always figure out what you need to put into inverse t by doing this. Okay. Inverse t always wants all the area to the left of the value you're looking for. So if it's a 95% confidence interval, this is 95% in the middle. That means there's 2.5% on either side. All the area to the left of t star is 97.5%. So it's going to be TCDF, not TCDF. I've still got the hypothesis test in my mind. This is inverse t. Inverse t of 0.975 with 9 degrees of freedom. So I do that here. Inverse t, 0.975, 9 degrees of freedom. I get 2.262. Okay, that seems like a reasonable critical value. Most of them are somewhere around 2 usually. That's what I got last time I did this too. Fantastic. If you don't have that inverse t function, you will have access to the tables. If that is the case for you, if your inverse t function is not on your calculator and you can't get it to work, watch the video that I've posted on how to use the t-table to calculate this. You will have a 95% confidence interval with, it'll be a two-tailed probability of 0.05 with 9 degrees of freedom, and that should be the number in the table for that. Okay. From here, you could go ahead and calculate this out. I would rather use t-interval at this point. So we've got t interval here. That's under stat tests. You've got data in L3 that you can use for t interval. Data in L3. Your frequency is 1 and your confidence level for this example is 95%, 0.95. So you can calculate this. You get negative 4.61 to negative 0.99. Yep. Okay. So this is our 95% confidence interval. And we can see from this what we would write for our description here. I would recommend, if possible, pause the video, write your interpretation of this confidence interval in context before I write it down. Pause the video, go on. You can do it. So this would be my interpretation. Yours almost certainly is different, but it should say something similar. We are 95% confident. You need that part for sure. That the true mean resting pulse rate after the experiment, you should have true mean resting pulse rate. That's the variable here. That should be in your interpretation. The true mean resting pulse rate after the experiment was between 0.99 and 4.61 beats per minute lower per person than before the experiment. So again, if you wrote your interpretation and you wrote something like the difference in mean resting pulse rate before and after the experiment was between 4.61 and 0.99, that is not wrong. That is a correct interpretation of this confidence interval. However, as a statistician, yes, you're crunching the numbers. Yes, you're using these mechanics to come up with confidence intervals and things like that. You're also telling a story. And it's not a very interesting story to say that there's a difference somewhere in here. It grabs someone more to say something like, the true mean after the experiment was this much lower than when they started. Because that's what we're really trying to get at, was how much of an effect did the exercise make? Well, it lowered the pulse rate, the average pulse rate of this sample here, somewhere in here. Okay? So using this directionality here, saying lower, is more impactful. It is not wrong to simply state that the difference is somewhere in here. We're 95% confident that the true difference is somewhere in here. But if you can make it mean something, if you can say something more specific, it would be better to do so. Okay? All right, so we are through with this example. We've done the hypothesis test. We've calculated and interpreted the confidence interval. I'll be honest with you, there's really not much left in this chapter because it's really just a rehash of a one sample t-test with the fact that you're taking two related data sets, calculating the difference between them, and then just using essentially a one-sample t-test. But since we do take the differences, we call it a paired t-test. Now, for the AP test this year, they have stated that since it's online, since it's so short, they are making the questions more big idea based. Like, you could potentially have all of the formulas, all of the mechanics, everything out in front of you when you take the test. It's essentially open notes that way, and I think that would be a smart way to take the test, to be honest with you. Unless they come out with guidance saying you're not allowed to do that. If they do, I'll let you know. But chances are the questions they're going to ask aren't going to be able to be answered simply by plugging in numbers into formulas. They're going to want you to show that you have a true understanding of why you're doing this stuff for a particular example. So I don't know what the test is going to be like. I never do. This year is no exception. But I would expect them to have you write responses that get more towards concepts and away from just plugging and chugging, if that makes sense. So what I'd like to talk about is, if you have your textbook handy, grab it real quick. And I want to talk about problem number 5 on page 649. Number 5 on page 649. Okay, you've got your book. You've already read this problem. Fantastic. I need to read it again because it's been a little bit since I've seen this one. Okay. So I hope I don't get taken down on YouTube for this. So that's going to be a problem. This is a textbook problem. I'm just reading from the book. So they want you to design an experiment to see if the presence of sexual images in an ad affects people's ability to remember the product. Okay, so this is something that marketing people have been wondering for a long time, and I'm sure there have been studies done similar to what they're expecting you to come up with here. Do sexual images make advertisements more memorable? Memorable? Memorable. Well, unless you're going to copy an experiment that's been done in the past, you've got to come up with one. And let's say, for part A, they want you to describe an experimental design requiring a matched pairs t-procedure. Okay, that's essentially what we did here. A paired t-test is also called a matched pairs t-test to analyze the results. So you need to design the experiment in such a way that you can utilize the difference between two data sets because they're not independent. That's why we take the difference. So how could you design the experiment so that you've got data that looks like this? Like, not necessarily these numbers, but that you would do the same procedure that we just did. Well, you need two sets of data. But you need those two sets of data to be paired somehow, to be related. So what could you do? Well, the key might be here. Okay, for a paired t-test, or a matched pairs t-test, it's usually common to see both sets of data refer to the same people, or the same experimental units. So, what we want to do here is we want to somehow show the same group of people two different sets of ads so that we can compare how likely they are to memorize them. So how about something like, we want to show the same people ads with and without sexual images. Okay? Those will be the two sets of data, with and without, for the same people. So we know how we want to set up the experiment, but how are we going to get data values here? We also need to come up with what the data is going to be. How can we determine whether something is more memorable or not? Well, you could simply record how many ads of each type each person remembers. Okay. Could record how many of each type. So maybe you show them 10 ads with sectional images and 10 ads without. And then maybe the next day or something like that, bring them back and be like, which products were advertised? And based on what they say, you will be able to classify them as with or without sexual images. Just record how many of each. Are there any problems with doing the experiment this way? Well, it might help to think back to the conditions that have to be met for this kind of test. We've got randomization. If we're doing an experiment here, what needs to be randomized is not the people themselves, but the treatments that those people get. So how could we randomize the treatments for this experiment? Well, what are the treatments? Showing them the ads, right? We're saying there are maybe 10 of each. So how can we randomize? We would just randomize the order of the ads. If you didn't randomize the order of the ads, that might affect the results, because maybe if you give them, let's just be extreme here, all the ones without sexual images first, and then all the ones with afterwards, they might be more likely to remember the ones that came last, simply because they came last. So we want to randomize the order to get rid of that potential bias. Okay. So I think this is a pretty good summary of the experiment that would use a paired t-test or a matched pairs t-test. Okay? The same people would be given both sets. Okay? For part B, what it asks is describe an experimental design requiring an independent sample procedure to analyze the results. So we've got the same setup. We still want to run an experiment, but we don't want it to be a matched pairs test. We want it to be the type where there are two independent samples. So we want to do the same thing, but now with two independent samples, what would need to change for that here? Well, if we want the samples to be independent, we can't possibly use the same group of people for both, right? They would have to be different. Okay, so we could place people into two groups. One group given ads with sexual results, with sexual images. One group given ads without sexual images. Record how many ads each person remembers. So all we've changed is instead of showing everyone both types, every person only gets one type or the other. We record how many ads each person remembers. We still need to randomize somehow for this experiment. We would randomize the treatment, which is which group they're in. So the groups are determined randomly. Randomly place people in group 1 or group 2. Okay. Assuming these people don't have something in common that would influence the results, by randomly putting the people into two groups, you have now created two independent groups. Once you got this data of how many ads each person was able to remember, you would be able to do a two-sample independent sample t-test for the results, okay, to determine if there was a difference. Okay. You might still have some concerns about whether the group that got the sexual images was really different in some way than the group that didn't get the sexual images. You are taking into account the fact that there could be differences among those people by randomizing which group they're in. If you were still worried about it, if you could possibly increase the sample size, the more people you have in each group, the more likely those two groups are to be pretty close in how they would react on average with how many ads that they would remember. Okay, so I would expect at least one of the two problems to be pretty heavy on asking questions, not exactly like this, but where you're not really plugging and chugging and calculating stuff, where you have to understand what it is they're asking. Do you know what the difference is between a matched pairs t-test and a two independent sample t-test? Okay, you're not going to be able to find that on a formula sheet. That's something you just have to know. Right? So, things could change, but at this moment in time, I am planning on releasing a part 3 video for chapter 24 that is another example similar to this one, where we will go over the entire hypothesis test, the confidence interval, all of that good stuff. If you want to see that video, feel free to watch it. If you feel like you're good after seeing these two videos, you don't need to necessarily watch that one. You will be expected to complete the homework assignment and submit that on Canvas for next Tuesday. There will be a quiz over chapter 24 that you will also take on Canvas. And like I said, this is the last chapter we're going to talk about. So starting after the quiz date, on the next day, the next e-learning day, you will have practice problems to work through. That will serve as our review for everything. Okay. If you could take some time over the next maybe couple weeks, look back through your notes, look back through the textbook, and start writing down the chapters or the concepts that are a little fuzzy for you, that you might need a little extra review with, that will be very helpful. Because in addition to the review problems that we're going to be going through, I will be assigning you problems, you'll work through them, and now I will post videos detailing how they go. So you will get answers to all of the questions that you're asked to go through. But if there are concepts that you need some extra help with, the stay-at-home order and the quarantine are actually working in our favor, because you know, for instance, that I have nothing better to do. Not that other things are better. But anyway, you can let me know, and I can give you one-on-one instruction on the exact concepts that you think you need more review with. Okay, I've got my book here. I've got other resources that I can pull out, and we can go through anything that you're struggling with, and we can hammer that out before the AP test comes around. I'm confident in that. Okay, so this is actually a unique opportunity to get one-on-one help, if that's what you want. I'm totally willing to do that. Okay, so part 3 video, optional. If you want to watch it, great. If not, go ahead, crack open that textbook, start working on the chapter 24 homework. You can look forward to a quiz and some review problems to work with, and we'll talk about those as we get them. So for now, have a great day, and we'll see you next time.